simple. They're not that hard. Okay? So whenever you see this, x squared equaling a negative, what's your answer? No real solution. Don't take the square root when it's x squared equals a negative. Now make sure it's not negative x squared equals a negative, because then you can still divide by -1 and get an answer. Okay. So that's using what they call the square root property. You do not have a linear term, so you go for it. Okay, back to the top. This one has a linear term. Okay, we need to factor this. Actually, before that, you do have to make sure it's set equal to 0. So this is going to be similar to what we did on the graphs when we graphed it and we found the x-intercepts. That is something you can fall back on to help you out with this if you need to. So we have to find out what two things did they multiply together to get this quadratic. So what multiplies to -36? That's to -5. Nine and 4 going to 36, so -9 and 4. Oh, yeah, duh. Okay. So split the middle. It's easier if you put the first number or the negative number first. Then you don't have to worry about dividing by negative. Okay, we did a lot of that yesterday, so is that process becoming ingrained enough that you can do it in your sleep? Wake up with factoring nightmares. I can't find two numbers that multiply to 10 and add to 11. There are not factorable ones where the roots are either irrational or they're like square roots or they're answers. They're not rational roots like this. Okay, so from here, remember, this equals 0. I'm multiplying two different things. How many factors do I have? 2. 2 factors. Each set of parentheses is a factor, so I have 2 factors. So if I have 2 fifths, and I have a number in each of these fifths, and all I'm telling you is that when I multiply these two numbers, I get 0. What has to be true about one of these numbers? Negative. That equals 0. So one of them has to be 0. Okay? So these are the 2 fifths right here. So if I multiply this parenthesis times this parenthesis, it's equaling 0. That means either this has to be 0 or that has to be 0. So what are my two options? What makes that 0? What number plus 4 equals 0? What number minus 9 equals 0? 9. So how we work this out, if you write these steps down, if you like the steps, so either x plus 4 equals 0 or x minus 9 equals 0. And then we solve each of those. So we get x1 could be -4 or x2 could be +9. Those are your solutions. All right. So how this might look, let's say they give us 4x squared plus 4x equals 8. And all the instructions do is say to solve. Almost there, kiddos. So what does it equal right now? 8. Is there a linear term? Yeah. So can we solve it for x squared if there's a linear term? No. So we have to do the factoring. So when we factor, it has to first equal not 8, but 0. 0. So we say set equal to 0. That means move everything off the other side. So this plus 8 on this side, when I move it over, becomes a minus 8. What else do you notice about this problem? 4, 4, and 8. Do we have a common factor? Yep. Okay, so we're going to look for a common factor, divide if one exists. So if I divide by 4, everything has to be divided by 4. 0 divided by 4, of course, will be 0. Where does that 4 have to go? And common factors will go out here. Now that is not going to affect our answers at all. So we can pretty much ignore the 4 from here on out. Okay. So let's factor x squared plus x minus 2. So what multiplies to negative 2 and adds to 1? It's one of those easy, tricky ones. Almost. I have to add the positive 1. So negative 1 and 2. Negative 1 and 2. 2 only has so many factors, 1 and 2. So it has to be some sort of combination of that, or it would not be factorable. So to find the answers, we set each of these equal to 0. So I say you set the factors equal to 0 and solve. So x plus 2 equals 0, which means x1 is minus the 2 over, you get negative 2. Or x minus 1 equals 0, so x2 is positive 1. So those are your two zeros, those are your roots, those are your x-intercepts, those are the points where it crosses the x-axis. Right. So on this worksheet, one side is entirely the square roots, so they don't have linear terms. The back side is the ones with where you have to factor. Now, not all of them you have to factor. Okay, this worksheet starts off, look at number 1. Guess what? It's already set. It's already factored for you, so you just have to take each of these equal into 0 and find your two answers. Okay? So you get down to number 5, then you have to start setting equal to 0 and factoring. So
if you have the multiple, try and add always to the same x.
Are they the same? Exactly. And not exactly. Not all the time. They're opposite. That's cool that you noticed that. I'm glad you noticed that. Okay. Like these two numbers here, your answers weren't -1 and 2. It was +1 and 2. Not always. There are certain times, if you can figure out when that happens, it's going to help you out. It's not always going to be like that. That is one of the shortcuts that sometimes works. If you can recognize when it does work, you can save yourself a lot of time. But it doesn't always work. That's very perceptive of you guys to kind of take that out already. That's cool.
What side do you underlook?
Huh?
And it may not be down Monday.
What?
I have a dentist appointment, but I don't know when it is.